Okay, again, find all rational root theorems. This is the rational, find all rational zeros you have to use the rational root theorem for anything larger than a quadratic. Now, so if it was a quadratic, we'd be using quadratic formula, we'd be using factoring, all right? But since this is a cubic, you can't do that. So what we have to do is we have to resort to the rational root theorem. Now my P is here, my Q is here. Just so happens that they are the same thing. So, which means 1 over 1 is just 1. 1 over 2 is just 1/2. 2 over 1 is just 2. Just 2. And then 2 over 2 is actually 1. We already have him. So it looks like I have 6 possibilities. All right. And so what I want to do is I just want to test one, and I want to see how it works. And then from there, I'm going to, if I find one of them, that means this third degree, I've factored one of the factors out so that he'll become a quadratic. Then I can use the AC method or the X method, whatever I have to do. It looks like I'll probably be using the AC method. So let's go ahead and just try 1. I just start out always with 1 or -1. 2, 7, 7, 2. 2, 2. That's 9, 9. That's going to be 16. That won't work. Okay, so now let's try -1. Okay, drop a 2. That'll be -2. That'll be 5. That'll be -5. That'll be 2. -2. Got it. Okay, so -1 is one of my factors. Okay, now to make sense of this, what we have, this result, okay, means that I have x minus 1 as one of my, no, x plus 1 as one of my factors of this polynomial up at the top. Cover them up. Right here, okay? So it means then, if I look through here, looks like -1 is in all of them except this guy, so I can cross him off. Okay? And then what's left is I have, so he's one of my roots right there, and I can just circle it. Now what I have left is a 2x squared plus 5x plus 2. Now if I were to use, if this was say number 5 or 6 and I had to multiply that out, if I multiplied this out, I would get this. I would get that right there. Okay? What I'm doing is I'm doing the backward situation from 1 to 6. All right? It's completely backwards now. I'm going the other direction. I'm factoring instead of multiplying. Okay? I'm dividing things out. All right, so I have a quadratic. So because this is a 2, I will have to use the AC method. So I could keep going and do synthetic division with the other 5. No, I already did 1, 2. So I got 4 more other ones. I could do that. Okay, that's totally fine. But I'm going to go ahead and do the AC method. So 2 times 2 is 4, and that has to add up to 5. So factors of 4 that add up to this middle guy would be 4 and 1. So the way that we write this is 2x squared plus 4x plus 1x. Okay, and bring him down plus 1. All right, so split it down the middle. Factor out your common terms so that you get an x plus 2. This guy, there's nothing to factor except, I don't know why I wrote a 1, 2. Nothing to factor except the 1 so that you get an x plus 2. Now I put the 1 out in front because I will be lassoing this guy. Okay, so now I have x plus 1, I have 2x plus 1, and I have x plus 2. So the factors that will give me 0 is -1, -2. Okay, so I can look at my choices there. -1 and -2. So don't worry about this multiplicity. He's going to show up over here. I'll talk about that in a second. But it can only be B or C now, and then we have to ask, is it -1/3 or -1/2? -1/3 is not even one of my possibilities. Okay, so I can cross him off, and actually the answer is C. But let's go ahead and see where the -1/2 came from. The -1/2 came from setting this guy equal to 0. Okay, just like I did here. But this you can do in your head. This you might want to do a couple steps. You know, when it's fresh, hopefully you can do it in your head. But I'm going to be moving that 1 over to the other side. Okay, then I will divide by 2. But he's got to become negative. So dividing by 2, I get x equals negative 1/2. So there's my other guy. All right, so I have x is negative 1, negative 1/2, and negative 2. Those are the 3 locations where the polynomial hits the x-axis. All right. So now let's look at 22. So 22, we have 2x to the third minus 3x squared plus 1. All right. So what we do here is we look at the p and the q's, and it looks like I just have 1. The q is just 1 and 2, so it looks like p over q would just be 1 over 1, which is 1, and then 1 over 2, which is 1/2. So I only have 4 possibilities. All right. Now if you notice though, you'll see there are things called multiplicities. Over here, when we had these, you guys could easily have graphed this guy because you know it passes through negative 1, passes through negative 1/2, passes through negative 2. But multiplicities means is that when you graph it, you're going to get a bounce. Okay, you graphed plenty of those. When you have a multiplicity of 2, that's what it looks like. When you have a multiplicity of 3, that's what it would look like. All right, you've done plenty of those. So if it shows up, it's fine. But what does it look like when you're doing the algebra? All right, so let's go ahead and get started here. We're going to go ahead and start with a positive 1. Okay, now I'm going to do 2, negative 3. Now I am missing an x here, so technically I do need to have a placeholder. So I will put a 0, then I'll put a 1, drop it, 2, that's 2, negative 1, 0, 0, nope, sorry, negative 1, negative 1, negative 1. Okay, I'm going to start over. 2, 1 times 2 is 2, negative 3 times, plus 2 is negative 1, multiply, add, multiply, 0. Okay, so it looks like positive 1. Okay, positive 1, when I plug in a 1, I get a 0. So this needs to have a sign change in this representation. But now I have 2x squared minus x minus 1. All right, now I'm going to factor that the way that I did. Now, I could keep going, though. Okay, I could keep going and do the rational root theorem all over again. All right, but I'm not. I'm going to factor it. So factors of negative 2 that add up to negative 1. All right. 2 times negative 1 is negative 2, and then this guy is the target, so I have negative 2 and positive 1. So this means I bring them all down just like I did in this example here. Okay, he'll come down 2, but we're going to get 2x squared minus 2x. This guy comes down 2, that'll be plus 1x, and then this guy is negative 1. So what can I factor out? 2 and an x. Let's cut that in half. We get x minus 1, and then over here we have an x minus 1 as well. Okay, so we have 2x. We're going to lasso this. And we have x minus 1. But remember, we have x minus 1 over here too. Okay, that, ladies and gentlemen, is what happens when you have a multiplicity. You actually have the same factor twice. All right. So how that pans out graphically is that it will bounce off the x-axis at x equals positive 1. Okay, so we would write x equals, if this equals 0, x equals 1 with a multiplicity of 2, okay, comma, 2x plus 1 to get 0. It's the same thing over here. All right, it was negative 1/2, and that's your final answer. All right, so multiplicities mean these guys will show up twice, okay? Now, if you tried, what would happen then is you would have to start over the rational root theorem if you wanted to keep testing them. Okay. All right. So that's rational root theorem.